All right, let's jump right in. We're going to pull back the curtain on how these huge, really complex applications get built. You know, the kind of apps that basically run entire companies. We'll be looking at the official blueprints from Microsoft's guide on enterprise app patterns.
But first, let's start with a question I think we've all asked ourselves in a moment of pure frustration. Why do these massive, super important apps sometimes feel so fragile, right? You click one button and suddenly something totally unrelated just breaks. What is going on there?
Well, a lot of the time, the real culprit is something called a monolithic app. And honestly, the best way to picture this is to think of a giant, wobbly Jenga tower. Every single piece is jammed in there, all connected. You try to pull out just one block, no matter how carefully, and the whole thing is at risk of just collapsing.
And here's the more official definition. The key phrase to really latch onto here is tightly coupled. It means everything is just tangled up together like a giant ball of yarn. This design makes fixing bugs, or adding new features, or just doing basic maintenance an absolute nightmare. It's so inefficient and it's incredibly risky.
So if that Jenga tower is the problem, what's the solution? Well, it really all comes down to one single core idea: building for adaptability. We just need a much, much better blueprint.
And this, right here, this just lays it all out. We're basically swapping that brittle, tangled Jenga mess for a set of Lego bricks. See, instead of being tightly coupled, our parts are flexible and modular. You can test each brick on its own, you can easily swap one out for a different one, or add totally new bricks without shattering the whole thing. It is a total game changer.
The source material really says it perfectly. The fix isn't some small tweak, it is a fundamental shift in how you think. You partition the app, you break it up into these separate, loosely coupled pieces. That is the blueprint. So, how do we actually do that?
Okay, so our first major tool in the toolbox is a design pattern called Model View View Model, or just MVVM for short. Think of this as the master organizer for our app's code. It's specifically designed to bring some serious order to all that potential chaos.
Now, to make this idea really stick, let's use a simple analogy. Just imagine your entire application is a restaurant. MVVM is what defines all the different roles and jobs to make sure that restaurant runs like a well-oiled machine. So here's the official technical diagram. And yeah, I know, it might look a little abstract at first, but it actually maps perfectly to our restaurant. You can see the view model, and the model, and these really clear lines showing who talks to whom.
Let's break this down. First, you've got the view. This is your waiter. The waiter takes the customer's order and brings out the food. It's the user interface, what you see. Then you have the view model. That's the chef back in the kitchen. The chef gets the order from the waiter, pulls the ingredients, and does all the cooking. This is where all the logic lives. And finally, you have the model. These are the raw ingredients in the pantry: the flour, the sugar, the raw data. Now here is the most important part. The waiter talks to the chef, and the chef uses the ingredients. But the chef doesn't know what the dining room looks like, and the ingredients definitely don't know who the chef is. That separation is everything.
Okay, so we've organized our code into these clear roles. But how do all these different parts get the tools they need to do their jobs? And how do they talk to each other without getting all tangled up again? This is where smarter connections come in.
First up is something called dependency injection. And the absolute best analogy for this is a universal power outlet. Instead of hardwiring every single lamp and appliance directly into the wall, you just install outlets everywhere. Then you can plug in whatever you need, whenever you need it. This makes your code so much more flexible and way easier to test because you can just plug in a fake test version of a component whenever you want.
So who manages all this? Well, there's one central container that's in charge of all these connections. You can think of it like the master electrician for the entire app. It's the one that installs all the outlets and knows exactly which appliance to plug in where and when. So dependency injection is fantastic for when one part of your app directly needs another part. But what if they need to communicate more indirectly? What if they shouldn't even know that the other one exists at all?
And for that, we use something called the messenger pattern. Honestly, just picture a town crier from the old days. He walks into the town square and just shouts out a piece of news. He has no idea who's listening, and frankly, he doesn't care. Anyone in the crowd who's interested can listen for the news, that's called subscribing, and then react to it. This is what true decoupling looks like.
And this diagram from the source really brings it to life. See, you've got publishers on one side, just shouting their message out into the world. In the middle, you have the message itself, just traveling along. And then on the other side, any number of subscribers can choose to listen in. And the key thing is, the publishers and subscribers never, ever have to meet. So, we have our organizer, the MVVM pattern, and we have our smart connection tools, dependency injection and messengers. Let's see what happens when we put this all together and actually build an app with this blueprint. And this is just fantastic. On the left, you see the complex architectural blueprint for this sample eShop app. All those boxes and arrows, that's the patterns we just talked about. And on the right, that's the beautiful, functional, and most importantly, stable application that was built from that very blueprint. All that complexity on the left is what enables the elegant simplicity you see on the right.
So what's the big takeaway here? Why go through all this trouble? It's because you get an application that is truly built to last. It becomes adaptable, so when the business needs change, the app can change right along with it. It's maintainable, meaning you can fix one bug without accidentally creating 3 new ones. And it's testable, which means way higher quality from the very start.
And that really leaves us with a final thought. This core idea of partitioning things into these separate, loosely coupled parts is just so powerful. So the question to think about is, beyond just writing code, where else in our work or even in our lives could this principle of separating concerns help us build stronger, more flexible, and more resilient systems?